Recording.
All right. Welcome everyone on this beautiful afternoon where we are going to share our time with Desiree Agterberg from the University of Applied Sciences of Amsterdam, and where she is working on her PhD on applying history of mathematics in the classroom. Though better descriptions she's going to probably give you in a moment. Well, Desiree and I go way back. We know each other from mathematics studies, and I know that after that she worked as a teacher for 7 or 10 years or so, maybe even more. And after that, she became a teacher trainer in Amsterdam. Very much appreciated, I've heard. And then she started her PhD, I think 3 years ago or so. You are going to tell us when we're going to come to your defense, maybe, or not. Is that known yet?
No, it's not. But I will say a little thing about that. Yeah.
Wonderful. So, well, actually, I'm going to stop talking, and the floor is all yours.
All right, and I'm going to start sharing. Maybe you can confirm you can see my slides.
Yes. Yeah.
Okay, great. Thank you, Rogier. Thanks everybody for coming. I hope to make it an interesting presentation. I'm very happy to share the work I've been doing for a few years with you, and I'm interested in what you have to say about it. I called it the 4S model for selecting, analyzing, and designing tasks, and I'm going to explain all that in the next hour or so. Yeah. I made a structure in 2 parts, basically. After a short introduction, I'm going to talk about the 4S model first. I call that part 1. Then I will wait for some questions, maybe some clarification questions on that part. Then the second part, I'm going to share some things I did with the 4S model in my classroom. We did an intervention. Then afterwards, you can ask questions on that, and I hope to have a fruitful discussion for the last half hour or so. At least that's what my idea was about how this 1.5 hours should be structured. Rogier said some things about my work, and I thought it was relevant to mention that a little bit for the people who don't know me. And I think, some of the things I did before are relevant for what I'm doing now. I did a master's thesis in history of mathematics way back. I did know Rogier by then, actually, but I did a master's in Utrecht. Professor Henk Bos was the professor that I studied with. Then I was a teacher in secondary education for about 10 years. Then I started working at the teacher training program in Amsterdam for both lower and higher secondary education teachers. And I'm doing that for a little over 10 years now. And in 2019, I started my PhD, also in Amsterdam. I'll tell a little bit more about the team later. I've always been working on how to use history of mathematics in the classroom, and I also think it's important to have materials for that. So I've worked together with Janine Daams, who works in Utrecht as well, to translate a book on history of mathematics and to write several articles for Uitlides, because we think teachers should have materials to work with if you want them to use history of mathematics in the classroom. And internationally, I cooperate in a group that's called HPM, History and Pedagogy of Mathematics Study Group. And there are a lot of people working on this theme, and it's very interesting to share our work across nations. Well, that's so far about me. Then I want to start off with some quotes that I collected from, the years that I was a teacher in high school, but also now at the teacher training program. And I think it's quotes that people will recognize when they have been mathematics teachers themselves, from pupils who, for instance, would ask you, why does a circle consist of 360 degrees? And this is actually a slide that I use at the teacher training program in Amsterdam. And I ask my students, do you know the answer to this question? Or do pupils actually ask you this question? Well, I have some more examples. On primes, are there infinitely many? How do you find them? Is there a pattern? Or for instance, why is mathematics called wiskunde in Dutch? Do our teachers even know that? Because in French and in German and in English, the words are pretty much the same, but in Dutch, we have another word for it. Why do we use the letter X for writing equations? Something, well, I think most people will have asked themselves or have pupils ask them. How did they actually calculate all the decimals of pi? And what when they did that without a calculator, how would they have done that? When did Pythagoras live? How did he write down his theorem? Especially if he didn't have the notation that we have. And the last one, where does our number system come from? So these are, I think, relevant questions to math teachers. They should have answers to, or they shouldn't be afraid of this kind of answers. But this has also the potential of, well, making interesting mathematics activities. It's not just a question from a pupil, but you can use it yourself for making interesting classroom activities. As a teacher trainer, I think it's important to convince my students why they should know something about history of mathematics, and I expect a lot of the people that are here today will agree or could come up with similar reasons. But I think it's good to share some. I think well, yeah, you can, as you can see, there are a lot of different reasons. I've listed here 5. It can deepen your knowledge. It can help you develop a personal view. It can extend your pedagogical repertoire. It can show you conceptual difficulties and extend your range of classroom activities. These are all very different reasons or motivations for using history of mathematics in the classroom. And in my project, I'm going to place a bit more focus. But these are all, I think, reasons for teachers to know history of mathematics. In my PhD program project, I focus basically on cognitive reasons for using history of mathematics. So I wrote up my main research question here. How can history of mathematics be used to raise the cognitive demand level of tasks? Well, as I said before, there are a lot of different reasons for using history of mathematics, but I'm going to focus on the cognitive ones. You see here, I use abbreviation, HOM. You will see that in a lot of slides to come. And the second focus I have in my PhD project is on teacher training. So I'm developing materials or tools that we will be able to use in teacher training programs to help in-service teachers or prospect teachers to design activities. The team of people that helps me with this project are Professor Oosdam from the University of Amsterdam, Professor Jansen from the University of Leiden, and my co-promoter is Bonne Zijlstra, also from the University of Amsterdam. So far the introduction, so let's get to the content. I'm going to start by talking about what I call the 4S model. I want to share a little bit on history of mathematics in education in general, and tell you about a textbook analysis that I did, which eventually led to the creation of the 4S model, and I will relate that to the cognitive demand. And then if people have questions on this part of the talk, I will try to answer them. For the first part of my PhD project, I focused on creating a tool that would assist mathematics teachers to design lesson activities where they would use history of mathematics. So that's what we're trying to get here, a tool. And I'm going to share a little bit of the literature on history of mathematics in education that is generally used. In an article from Uffe Janquist, he made a distinction between using history of mathematics as either a goal or a tool in education. It can be a goal in itself, or it can be used as a tool to reach other goals. You could say history of mathematics is a goal in itself because history of mathematics or history of science is a part of general knowledge. People should know where the science or the mathematics came from. That's a goal in itself. But there are also other ways of using history of mathematics where there are more, where it's more a tool for reaching cognitive goals or goals on the motivation level or cultural objectives. You see them listed here. With regards to cognition, you could think of history of mathematics supporting the actual learning of mathematics itself. So maybe show more coherence, do some guided reinvention, or reach higher mathematical levels through using history of mathematics. Then we have the tool for reaching more motivation with your students, with your pupils. For instance, to help understand that mathematics is a useful subject, that it can be applied. It can help the teacher to use a variety of classroom activities, and also to maybe interest people that are not so much STEM orientated, but are more interested in social sciences. But through history of mathematics, they get more motivation for the mathematical part. And I think also an interesting one is that history of mathematics can show that it's a human activity. For instance, how mistakes were made in history and how they turned out to be very useful, and that it's okay to make mistakes. And lastly, cultural objectives. History of mathematics can help to look beyond cultures, show diversity, and at the same time, a sort of universal language that goes across cultures. So that's on the why would we use history of mathematics in education. And then that's the why part. And now we get to the how part. How would we use it? And these things usually get a bit intertwined, the whys and the hows. But I want to, show you some different shapes and possibilities for content. I listed a few. We can have historical fragments, or they are also called snippets, by the famous Tsanakis paper, which you can think of as pictures, texts, exercises in curriculum materials, in textbooks. You could also have entire lessons or entire chapters or entire projects on history of mathematics, or use history of mathematics as a structure for a project. Another type of form to present history of mathematics in is by using original sources. So this doesn't say that much about the amount of history, but more in what way do we show it? Well, I'm showing an original source here on the right. Maybe you know it. It's a rather famous one, the famous Plimpton tablet. And something else to consider when you think about how I want to use history of mathematics is, do you use it explicitly or do you use it implicitly? So are you actually stating the names and years in which something was developed, or the reasons why? Or do you leave that out completely, but do you use the historical development as ideas for how you want to instruct the mathematics to your teachers? To your pupils. Well, when you there is a lot of literature already written on this subject, on using history together with pedagogy and mathematics. If you look at the literature, you will find a lot of textbook analysis. You will find that there is a focus on the use of original sources and on using history mainly in secondary and higher education. There is not so much done on the empirical side, and most empirical studies have a focus on beliefs and motivation. What does the use of history of mathematics do to, well, how do you think on mathematics? And there are some studies on teacher training, but this, well, actually was a way for me to find out what would be interesting to place my focus on. I'm going to show you now some examples from a textbook analysis I did myself with Dutch textbooks. The examples I'm going to show you in this part are not translated, so they are in Dutch, but in the second part of my talk I'm showing some examples that have been translated. I have analyzed several books for 12, 13-year-old pupils. I think, well, we know these are the notorious ones, so to speak, for Dutch education. Getal en ruimte, moderne wiskunde. And also I studied Wageningse methode and the new textbook series Kern, which actually advocates itself as a textbook series that uses a lot of history of mathematics. So I went through these books and I looked at the different shapes and content that was presented there. And I'm showing you some examples. This is a clip from the Wageningse methode. Here the word algebra is explained. This is actually something that I also use in my teacher training program. It's interesting to know where this word came from. So this is a small fragment from a book, Wageningse methode. Here we have another. This is a very typical example of how history of mathematics is presented in the series Getal en ruimte. There they have these little boxes. It shows at the top that it's a historical bit. And here we have some biographical information on René Descartes. When did he live? And some anecdote on the fly on the ceiling that led him to create the coordinate system. This is a fragment from Kern, the new series, where the method from, or one of the methods from algorithmy is used to solve quadratic equations. And I thought I had a fourth one. Yeah, this is from moderne wiskunde. It shows the tablet I've shown you before. And it is the beginning of a project. This is a project at the end of a chapter, or actually it's not related to a chapter at all. It's a project in the middle of a book on counting on numerical systems. And these are the first two exercises. So I've shown you this to make clear what range there is between ways of using history of mathematics in textbooks, at least in Dutch textbooks for 12, 13-year-olds. And well, these are some typical examples. So you can find more of these. And this led me to to create some to create a system to organize this. I'm gonna talk about that in a minute. To put it into words, how would I describe the results from the textbook analysis? Well, the sizes from the clips vary from very small references to rather large. It contains texts, it contains pictures. The history is sometimes embedded in the mathematical information, but it's a lot of times also in a separate box, not so much related to a specific text or to a specific exercise, which means that the location of the information is sometimes rather arbitrary. For instance, the clip I showed you from Descartes. Yeah, when would you give some biographical information on Descartes? That could be anywhere in a chapter. There's not really a logical place for that. The fragments can have cognitive goals to help students support the learning of mathematics, or non-cognitive goals, like more motivation, what is it good for, in other cultures was mathematics used, etc. So these are some of the results. Well, this led me to try to make a range of ways in which history of mathematics is presented, and I made a model with 4 formats, and I'm going to clarify on that. I looked at 4 different criteria, which you will recognize from what I've shown you before. One of the criteria is size, the other criterion is the content, then the location of the fragments, and finally what's the reason or what's the purpose of the fragment, whether it's used as a goal or as a tool. And as a starting point, or maybe you should say a benchmark of my system, I used, well, let's say a typical or an average fragment for history of mathematics, which has medium size, could contain a text could contain an illustration. The location is rather specific in the chapter or in the instruction, and the goal of the fragment is to support the learning of mathematics. I called this format the snippet, which is a word I borrowed from Tsanakis and Arkavi, who wrote on this first. And the other formats also got names that start with the letter S, which leads to the 4S model. The second one, I named that a stamp, and I used that word deliberately to make clear that it's actually a small box which is a bit separate from the text, and which, well, it could be also in another location. So size is small, it can contain text or illustrations, a rather arbitrary location, and here the goal is mainly effective or mainly for the motivation part. So you can see, I think, here the difference between, well, not just size and content, but also why the history of mathematics is used. And then we have on either side two more formats. The largest one I called story, and the smallest one I called spec. The story is, well, the word really contains, I think, the idea of the format. It's a large piece of historical information. It supports the learning of mathematics. It's at a particular location and can contain text and or illustrations. And the spec is very small. You could say, for instance, just the name of somebody who devised a piece of mathematics, just a piece of text, and at an arbitrary location, and it has a more motivation or effective goal. So these are the four formats that we came up with based on the textbook analysis, and that these formats can be used for that, to look at textbooks and to check what formats do we find. But what I also want to do with this is have my my pupils, my students who are a teacher training to be teachers, use these formats to design activities. So they make a deliberate choice. I want to use a stamp, or I want to use a snippet, or I want to use a story. But I will get to that a bit later. Well, some examples on how these formats can be found in the books. So a spec can be a very small historical reference, maybe a name of somebody, maybe a lifespan of somebody, or a short remark on the etymology of a certain word, for instance, the word algebra that we've seen before. Then the stamp would be a small side note, some historical information not particularly related to a task on a somewhat arbitrary location. The snippet is a more substantial text, and it's related to a task, and it uses history of mathematics either implicitly or explicitly. And finally, the story is a coherent series of tasks and texts regarding a certain mathematical concept. I'm going to show some more pictures, and then I'm going to relate this to the cognitive side. This is these formats don't really go into that yet. So here is another example from Getal en Ruimte, a stamp on where the symbols for plus and minus came from. You recognize the layout, I think, which was the same from the picture on René Descartes I showed you before. This is a piece also from Getal en Ruimte on Pythagoras. It doesn't say anything mathematically. It just says where Pythagoras came from, where did he live, when he lived there. So there's no real mathematical information in it. Here we have some more examples from the same textbook. It's mainly are mainly side notes, but some contain actually mathematical information. I'm going to go a bit fast through this because the time is going rather fast. I have some more examples. This is also a fragment from the chapter of on Pythagoras, but this is actually an exercise where the students, they read the clip, but they also have to think about it and answer questions on it. And this is a story where the student is asked to do several different things, where Pythagoras is sort of a theme or the structure of the exercises. And I thought I had one more. Yeah, this is from Moderne Wiskunde, so another textbook series. And this is a story on Platonic solids, which also gets to the formula of Euler somewhere in the story. Okay, so that's for the formats. Then I want to relate this to the cognitive part, and for this I related it to a taxonomy from Margaret Stein, and in an article from Stein and Lane, there are levels of cognitive demand described. You could say you can use several taxonomies, or there are of course more taxonomies to describe levels of mathematical thinking. I chose this one. It has 4 levels from memorization to doing mathematics, and in the middle it's about procedures without connections or with connections. Well, you can read the description of the levels, but I think the 4-way division is rather standard. Also, we also know RTTI, for instance, different letters, but I think basically it's the same idea: memorization, procedures on 2 levels, and the final level actually being creative, actually doing mathematics. And I want to use these levels with my students to have them think about raising the cognitive demand level while using History of Mathematics. I'll give you some examples on how this would look like if you combine the levels of cognitive demand with History of Mathematics. So on the memorization level, you could say you can tell why we use the Greek letter for pi, or which digits it contains of. When we get to the procedures, you can actually show them a procedure of how they did something in history and have the students repeat that. For instance, a calculation that the Babylonians used. Well, it works like this, and just do the same thing. That's a level 2 activity. Then you could also have them think about it a little more. This is an ancient calculation. Does it look familiar? What do you think it's about? Maybe you can think about how they came up with that. Are there differences and similarities with other procedures that you know? And finally, on the doing mathematics level, you could look at historical problems, more open problems. You can do some guided reinvention. I gave you an example here from the circle. You can show them a picture that's on the papyrus rind and ask the students if they can use this picture to calculate the area of a circle themselves. So have them reinvent a piece of mathematics. So what I want to show here is that I think you can say History of Mathematics can be done at different levels, and the interesting part is how are we going to get our students or our teachers to get to the higher levels. Well, when we relate the formats to the levels, it looks like this. The smaller formats with the effective and more motivational goals are related to the first level, memorization. So the spec and the stamp are at the first level. The snippet and the story can be, well, at the lower level, procedures without connections, but depending on what is done in this exercise or in this text, it could be on the higher level, procedures with connections, or the actually doing mathematics. And this picture is very important for how I want to use the model for designing activities at a higher level. It's going to come back in 2 slides. What can we have our teachers do with regard to raising cognitive demand with use of History of Mathematics? Well, if you check the textbooks, you will find a lot of stamps, more stamps than snippets or stories. So you can have the teacher that uses the textbook try and extend stamps to snippets by connecting them with tasks or connecting them with instructions, and not just simply read the text, but actually make a connection with the mathematical content, or ask interesting questions, the more mathematically interesting questions, and not just reproductive ones. I've shown you some examples of fragments from textbooks which were snippets, and these are some exercises that maybe a teacher would he would skip them, for instance, because they look a bit more complicated. Well, I think it's interesting to try and have our teachers design lessons or design activities with use of those snippets and not just skip them. So use them as an introduction, use them as a starting point for thinking, and don't use them at the end of a lesson, which maybe you will get to, which is the difficult exercise at the end, but use them as a starting point. And also use them as explanation and support for where mathematical concepts came from, for constructing them and for placing relationships between them. And finally, the story. I think the history can be used as a didactical structure to structure a piece of the curriculum, or maybe a larger piece of the curriculum, and not just as a project you do in a special week or if there is some time left. This is all regarded to what's already in the textbook, which it differs between the series, but not all textbooks contain a lot of history of mathematics. But as a teacher, you could also add to the textbook, of course, by choosing historical fragments from other sources, which can be other textbooks or other historical sources. And this is, these are the ideas that I think we can give to teachers during a teacher training program, and invite them to use history of mathematics this way and try to raise the level of thinking, of mathematical thinking. So what's happening in terms of the model are actually two things. So I think we can invite our teachers, our students, to make a development from pieces that are in the book, so the specs and the stamps that are in the textbook, and have them make a snippet or a story out of it themselves, and also have them try to, when an activity has a lower level, for instance, it's at procedures without connections, have them raise the level to procedures with connections, or to actually doing mathematics. And these two arrows, I think, point out how we can have, or how we can try to have our students raise the level of mathematical thinking through the use of history of mathematics. So that was part one, and maybe if there are some questions on more the clarification level, then I would like to answer them at this point, and then I'm going to continue with part two on how we use this model in a teacher training program. Is that okay?
Yeah, I think that's very good. So other clarification questions or a bit smaller things? I actually have one. Maybe I missed the point, Desiree. I was wondering, in your research question, you put it, how can history of mathematics rise cognitive demand level, if I grasped it correctly? And I was wondering, why should it?
Well, that's I'm not sure that's a clarification question. That's more of a discussion, I guess. But I would say, why not? Or I think we should try to reach the higher levels in mathematics education at any cost or at any way, and history of mathematics can be a tool to do that. So maybe that's more of a hypothesis on my side, but I think we should raise the cognitive level no matter what, and there are several tools to do that, and I want to find out if history of mathematics can be used to do that.
So maybe I'm misunderstanding a little bit. How do you mean cognitive demand? Because I was thinking like cognitive demand, that's more or less how demanding it for students' cognitive system, but you rather mean the level of understanding of mathematics understanding. Yes. Okay, no, so that was the clarification.
That was definitely
Thanks,
clarification.
that's helpful. Yes. Yeah, good. Rahir also has a hand.
Yeah. So I think it was all very clear so far, but one thing that sort of interests me, if you look at those books as you did, and you try to select the historical parts, well, in some books it's sort of clear because it indicates, as you saw with the tab, this is historical. If you take a bit of a radical standpoint, you could say that all mathematics presented in those books is historical, whether they say it or not. If they say this is a circle, then it goes back quite a few millennia. So the circle is a historical object in that sense. So how do you distinguish? I know, of course, it's a bit ridiculous what I say, but there is you have to draw a line somewhere. And how did you do that?
Yeah, I agree. And I think so. There is a bit of a gray area, I think, because some things are rather obvious when there's explicitly mentioning of history of mathematics in the text or in the exercise, and then there are some things where you if you know a lot of history of mathematics, you sort of recognize some implicit use of history of mathematics, but that's where the gray area begins, I guess. But I think on that part, it's not really a problem if you don't get it all, or if you just get the very visible parts from the textbook. I think, especially the students who look at the textbooks, or the teachers that look at the textbooks, will not see the less obvious fragments, I guess. So the main part is that we recognize the obvious ones, and we do useful things with that, I guess. And then for the gray area, it requires maybe too much expertise for our teacher trainers. But I think, well, we should accept that.
So just one response. So you sort of say, if you say it follows a historical presentation, or it somehow refers to some historical development, then that could be more implicit. But that is a cue for you that it's historical.
Yeah, but I think it's a cue for me that it's historical. So I would select it, and I could say to my students, this is historical, and you can see it because of this words, or because of this reason. But maybe my students won't recognize it. But well, yeah, that's okay, I guess. I can't have them recognize everything, I guess.
Thank you. Yeah, I think that's very interesting. Further, maybe discussion about general curriculum and history. I'm also wondering a lot. So if there are no more questions, then
I'll continue on the second part. Okay. Yeah. So for the second part, we did actually have students at my teacher training program use the model, and I want to share some things about that. For instance, the way we did the intervention, and also some of the results. But I have to warn you that on that part there is still some work to be done. So I'm certainly going to give some results, but definitely not everything is ready for sharing. The second, or the intervention we did, had a theme for the history of logarithms, and I'm going to say a little bit about that. Then I'm going to show you some things we found in another textbook analysis, where we looked at logarithms specifically. For the intervention, we devised an assignment we call a suitcase assignment, and I'm going to explain what we mean with that. And I'm going to tell a little bit more about the intervention and some of the results. So for this part, I think we made a little, we had another focus for the research, And the question we were trying to answer is, in what ways do in-service teachers use history of mathematics in a lesson design for the introduction of the concept of logarithms? And I don't know if a lot of you know a lot about the history of mathematics or the history of logarithms specifically, but you could imagine wondering what the word logarithm actually means. I don't know if everybody knows it. I can see Anna shaking her head. I don't see the other participants. Does anybody want to comment? Do you know what the word logarithm means?
Maybe they do, but not straightforwardly.
Okay, well, I will give away the answer. It's actually a combination of two words, the words logos and arithmos. So it's a combination of ratio and number. It says something about it. The logarithm is actually a number that's a ratio, or that has to do with ratios, and that's what makes up for the word. But this is also, well, I think interesting that maybe we know the concept logarithm, but we don't know what the word means. And knowing what the word means maybe adds to understanding what the concept of logarithm is itself. But no, that's maybe for later. I'm showing you here a quote from a book from John Napier, who we believe is the founding father of logarithms. It's a very nice quote. If I was teaching logarithms in high school myself, I would use this. It's a bit long. You can read the whole thing, but I'm going to point at some specific parts. Napier here says that he's annoyed with the time delay of doing lengthy multiplications, and also the many slippery errors that can arise when you do these kind of multiplications. So this is a time where there's no calculator, but there's a lot of multiplications being done for different reasons. But it takes time, and you can make a lot of errors while doing it. But then Napier says, I have found an amazing way of shortening the proceedings. So in this citation, or in this quote, it actually gives the reason why Napier devised his way of calculating that is now called logarithms. You can see here the inspiration that Napier used. He realized from a book he read from somebody else that there's an interesting relation between adding and multiplying when you look at this kind of sequences. If you want to multiply, for instance, 8 and 32, you can look at the factors or the exponents that correspond to that. 2 to the power 3 is 8, and 2 to the power 5 is 32. So if you add 3 and 5 and you go to 2 to the power of 8, you find the answer, which is 256. And this relation between adding and multiplying in sequences is actually the inspiration for Napier to come up with the concept of logarithms. Well, there's a lot more that can be said about that, but that was too much to put in this talk, so I made a very short list of possible contents that you could put in textbooks if you want to say something about the reason why logarithms were developed. And in the literature references at the end, you will find some more if you're interested in this specific part. But to go short, you could put in the textbook the reason why logarithms were developed, namely to shorten these lengthy multiplications. You could put in biographical information or illustrations. You could on Napier, or actually in this case, there were some Dutch people that helped with developing the concept as well. So that could be an interesting part to put in your textbook. You could put in the sequences I've just shown you, the arithmetic and the geometric sequence, and you could use the covariational reasoning that's happening there to introduce logarithms, or the specific geometric sequence that Napier used himself to define logarithms. You could say something about the meaning of the word logarithm, and finally, You could use logarithmic tables as they did back then, or use the logarithmic ruler that was used in education also in the Netherlands until quite some time in the 20th century. So these 6 elements, I looked for these 6 elements when I did a textbook analysis on the logarithms. And now I looked at some other textbooks as well. We see the well-known Getallenruimte, Moderne Wiskunde and Wageningse Methode here again. But then these were the textbooks for 16, 17-year-old students. But I also looked at material that was developed for the C2 project, a chapter. And I also looked at a rather old chapter from the Hebet project on logarithms, to compare very different styles on how to introduce logarithms. I want to show you one picture because I think it's really beautiful way to deal with logarithms. It's from the Hebet book, and here we see a picture from Olibe Bommel, the creation of Maarten Toonder, and he is used in this book or in these textbooks to discuss logarithms, where he has a pond in his backyard and he has some duckweed growing in the pond, and there actually are those 2 sequences there that help the students develop the concept of logarithms. If you have not seen this chapter before, you should really look into it. It's beautiful. But I'm not going to show you all the clips from all the textbooks. I have put the most relevant information in this table. You can see here that there's actually a lot of difference between how the textbooks introduce logarithms and the way they use history of mathematics in it. Some state reasons, some use the table or the ruler. Basically, all the chapters give some biographical information, except for the Hebet one. So you see there's a lot of difference here. I've also mentioned if it was mathematics A or B, and the C2 materials were mathematics C actually, but you can see the different choices that were made here by the different series. And what you don't see here is you see just the X, but you don't see how big this piece is. So you could say Moderne Wiskunde just has 1 or 2 X's marked, but actually that covers an entire page. And Wageningse Methode has also 2 X's marked, but that covers a rather small piece of the chapter. So you don't see the size of the information here. If you look at it in terms of the formats that I've explained to you in the first part, you can see that it's mainly at the level of stamps. So it's mainly side notes with historical information. Moderne Wiskunde actually relates the information to tasks, but Moderne Wiskunde has it placed at the end of a chapter, so not in between the instructions, but if you have finished the entire chapter and you have time left, then you get to the historical part, while the other series have it incorporated in the text that everybody reads. So that's an interesting difference. You can see that the C2 material actually has made rather a story of the historical information. And the Hebet is interesting. Maybe that refers to the question that Rogier just asked. It's a bit difficult, I think, to define here if they actually use the historical information. That's why I gave them a different mark. But at least what we see here is there are different formats used in the different textbooks. What we did next is use some of the clips of the textbooks in the intervention. And we did this in a course in my teacher training program in Amsterdam. And I taught a course there which was obligatory for everybody. It's a course on history of mathematics. and it takes an entire semester. We did this last year, so, well, due to well-known reasons, we had to teach it completely online. I taught it together with two colleagues, Peter Lanser and Lidie Wesker. Maybe some of you know them. And we had 20 students who took the course, and they all already had a teaching degree for lower secondary education and some years of teaching experience. And they were in our training program to get a teaching degree for higher secondary education. And this course was obligatory. During this course, we did a rather large data collection. They had to do 3 lesson designs as part of the course, and we have all these designs as our data. 2 of them were on logarithms, and I will get to that in a little bit more detail later. And there was a 3rd design on a topic of choice within a certain range. And we also had the students fill out questionnaires on the desirability and practicality of their designs. Were they happy with what they designed? And also we had them write down their ideas on the 4S model, because that was actually explicitly used in the training program. We gave them the model and asked them to use the model to design lessons with. The first thing we did in the course, we called it a suitcase assignment. And when we designed this for the intervention, we had the idea of actually bringing a physical suitcase to the classroom with papers in it and giving them those papers. But, well, eventually it had to become a virtual suitcase because we taught it online. In this virtual suitcase, we had fragments from different series of textbooks. So the Wageningse methode, getallenruimte, etc. that I've shown you before. We selected a lot of fragments from chapters on logarithms. We retyped them. So you could not see from which textbook they came from originally. They all looked the same, and they were all in a different order. There were some pictures, there were some texts, there were some exercises, and some of the fragments contain history of mathematics, but not all, and that was also a deliberate choice. And we gave the participants a limited time to design 1 lesson on the introduction of logarithms, and they were instructed to use at least 1 piece of historical information or a historical fragment. And then we were interested in seeing which fragment did they choose and in which way did they use it. We had them do it in a few steps. First, they had to read all the fragments, then they had to make a selection, then arrange the fragments, and finally they had to clarify on the choices they made. And they handed in the arrangement and the clarification. The suitcase contained, quick calculation, 22 fragments in total. That was 4 pictures, 8 texts, and 10 exercises. So these were all from the different textbooks, and some of them were historical. So from the 4 pictures, 3 were marked as historical. From the 8 texts, there were, it says 3, but it should be 4 marked as historical, because you can see 4 mentioned on the right side. And from the exercises, 3 were marked as historical, and I will show some examples, not all of them. This is a picture we put in the suitcase, so that's just the face of Napier, which is from getallenruimte. This is also a picture we put in the suitcase from the C2 materials, which shows a lengthy multiplication as a reason why logarithms were devised. This is from Wageningse methode, a short bio on Napier, where it says a lot about him, where he lived and what he did, but not so much mathematically what he did or what was the reason that he did it. And this is from the C2 material again, where they were using logarithmic tables to get acquainted with the concept of logarithms. So these are just some examples. I realize I showed them quickly, but I also realize it's getting close to 5:30. We counted which fragments were chosen and which combinations of fragments were chosen. In this table, you can only see the historical fragments. They also chose non-historical fragments, of course. So this is just one way of looking at it. And I think I'm going to go to maybe the interpretation, which is more interesting right away. Let me remind you that 20 students or 20 participants were in this course, and 17 of them chose to incorporate at least one piece of biographical information. So there were several clips that had biographical information, but 17 students chose at least one of them. 14, which is less, chose a fragment that mentions why logarithms were developed. So some just chose it was by Napier and he lived then and then, but 14 of them also chose a fragment that says logarithms were developed for this and this reason. Then there were 13 students that used the logarithmic table in their design, where when you study the designs more closely, we noticed that 2 times it was merely as an illustration and it wasn't really used in the activities, but just this is what it would look like back in the 17th century. And 12 students, which is little over half of the group, selected an exercise that we marked as historical, which required the logarithmic table. So it was interesting to see that one of the students did not include the table itself, but did want their pupils to do this exercise. So these are some of the results in words. And when you look at it in terms of the formats, 2 students were actually able to design a lesson that we regarded as a story, and the majority of the group either used it as a stamp or as a snippet. And you could say this is sort of a starting point. We did not give the students any instructions on the 4S model when they did this assignment, but after this assignment we did, and then we are going to see if the amount of stories and snippets is increasing and if maybe the amount of stamps is decreasing. Some remarks on this assignment. We noticed in the design already, but also in when we actually did it in the class, that there were some methodological issues here. The students had limited time to design the lesson, so that's obviously affected the quality of their design. Because we put the fragments out of their original didactical order, it was rather difficult for our students to make good decisions. And they had no choice to use other materials. They had to use just what was in the suitcase. So that could have also made things more difficult for them. Also, something that I think maybe underestimated a bit is the complexity of the concept of logarithms for our teacher trainers, in-service teachers, so for our students. They found the concept of logarithms rather difficult themselves, which also affected the quality of their designs for how they would introduce it to their own pupils. We had them design a lesson where they had to introduce the concept, where maybe it could have also been interesting to have them design a lesson where they would reflect on the concept using History of Mathematics. So then they would imagine they were having a group that already knew what logarithms were, but then do a lesson while using history. And also an important remark here is they did not have to actually perform this lesson with their class. It was just a design, and they could have designed anything, so to speak, knowing they didn't have to do it actually. So that's something that we are going to work on in the further parts of the study, where they're not just designing it at the table, but actually enacting it in the class, and see what that leads to. Okay, I'm going to wrap up this part, and then we can discuss further, or questions first and discuss further. What I'm still working on is the analysis of the other designs that we did in this intervention, and the analysis of the questionnaires. how they look at their own designs and how they look at the model. And what's going to happen in the coming months actually is we are having them we have another group who is going to do pretty much the same course together with Peter and Lydia again actually, but they have to actually enact their design in a class and they have to write a report on that. I want to interview them on how it was, maybe even do video, and we want to see what the pupils think of it. So that's next steps. Those next steps are planned for the project. Well, that's as far as I was able to present at this moment. So maybe I can answer some clarification questions first, and then we get into the discussion.
Sorry. Thanks, Desiree. Yes, I think that's very much to talk about here. But let's start if there are small questions, but maybe if you just have bigger questions and comments, you can also raise hands. Or put in a chat.
If you want me to stop sharing the presentation, then I will, but maybe there are some questions that require some slides, so I'm going to keep it up for now.
Well, I have a small clarifying question, maybe. So for the second part, I a little bit lost track of what the, for the first part it was clear. It was about using a history of mathematics to increase this cognitive demand.
Yeah.
The second one, it was about teaching, of preparing your in-service teachers, educating your teachers in training. But what could you phrase what the goal was more specifically? Maybe you did that, but I somehow lost it a little bit.
Yeah, no, I think I did for the first part. We looked at how they would use history of mathematics when introducing logarithms, but that's actually just an example of how they are using history of mathematics at all. And if we teach them the 4S model, which we did in this intervention, then are their designs changing, and is the cognitive level changing? Are they reaching the higher formats and the higher levels?
So it's basically, in a sense, about the effectivity of your training of a course on the 4S model.
Yeah.
To at least improve the level of the design, of the outcome of design.
Yeah, and then I think, sorry I interrupted you, but I think we wanted to see if they were able to use the model at all. And so we had, maybe, so to speak, rather low expectations, or we didn't want to get our hopes up too high. Are they able to use it at all, and are they happy with the designs that they make? And do we see a little bit of development during the course? Because in the end, they had to do 3 designs, and if we compare between the 3, do we see a shift? That's a little bit what we did.
So before, I think they wants to ask something, but could I say that this is, in a sense, a design study for a teacher course?
Yeah, but it's also mixed with, I think, maybe an evaluation of the model, because the model itself stands, but can be improved as well. And then there's the question of, if the model is okay, how do you use it in a course?
Okay, thanks.
Okay.
I think we've lost Anna, because otherwise she would have spoken up. So I take over the chair for a moment, and I saw Day has a question. So please
okay.
Go ahead, Day.
Well, thank you, Desiree, for the whole presentation.
Yeah.
And I think it's very interesting. And but you already answered part of my question in answering Rogier.
Mm-hmm.
But now I'm a bit lost, because I thought I heard you say that they didn't know about a model when they chose, but now you said, well, we're testing the model. So
yeah, I think I should go back to the data collection slide. Yeah, so at the very first session of this course, the first thing they did was we handed them the suitcase and they had to design the lesson. So they had no instruction on the model, they had no instruction on history of logarithms. They just got the suitcase and they had to make a design. And afterwards, we instructed them on the model in the second session and in the third session, and we instructed them on history of mathematics. And then they had to make the second design, which was also on logarithms. And then further on in the course, when we talked about some more beautiful history of mathematics, they had to design a third one. And there they had a rather free choice of topic. It had to be within a certain range, but it wasn't as specifically described as logarithms.
Mm-hmm. Then I'm wondering, because you presented them with things that were already thought of, but I mean, it's history, but it's of course history of mathematics, and you can change the history. But the parts they could choose from were already made by other people. I mean, they were from textbooks, right?
Yeah.
So, but that was on purpose, I assume.
Yeah, I'm not sure if I understand the question, but I think I'm going to get to this slide maybe to help give the answer. So we gave them, there was not just one picture or one text, so they had a choice on how they wanted to use history in their lesson design. And there were also fragments that did not contain history at all. Does that answer your question?
Yeah, a bit, because there was no room for them to think of something themselves.
No, not in the first one, but the second design was also on logarithms, and then they had the opportunity, if they wanted, they could use the pieces of the suitcase again, but they were also totally free to use other sources.
And probably there came up that it was a hard concept or something, or
well, no, in the first one as well, because
okay. Yeah.
We gave them the fragments that were, well, the structure was missing, as I said. We gave them pieces, and they did not see the didactical structure as fast as we would have hoped they would.
Yeah. Okay. So that's something that's really a prerequisite, that they need to know somehow a didactical structure before they can use the history, or
well, no, I don't think that, but I think what I'm interested in is how do they use history and at what level. And I think because we use the concept of logarithms, maybe they could not reach the higher levels. And if I had done this same type of exercise with parabolas or something else, then that it would have been the way they used history would maybe have been different, because they knew the concept, the mathematical concept, better.
Yeah. And did you also check what kind of method they used in their own careers?
I did not check formally, but I think I know.
Yeah, well, okay. So this was all for clarification. Thank you.
Yeah, that's fine.
Yoko has a very short clarification question in the chat. What was the title of the course?
It was called History of Mathematics.
Okay, so they knew they had to do something with mathematics in the design of the lesson.
Yeah, you mean with history?
Yeah,
with history.
It was. Okay.
Thanks. And I think Paul is the next one.
Yes, thanks for your talk. Very interesting and nice, Desiree. I think a few slides before the one you are showing now was the research question for the second part, wasn't it?
Yeah. And I think I already made a note that it's not complete for it's the research part it's the question for a part of what we did here. Yeah.
Yeah, because and this is a bit in line with Joke's question on the title of the course, which already sets the scene, of course, but also with Rogier's comment earlier.
Yeah.
So in what ways do they use it? Well, you also said, in fact, I am like evaluating the model, which is quite different to the research question. And you also said I'm monitoring the change over the 3 designs of your teacher students, which is also a different question, I would say, because then the question is how do they develop over the course? And also, yeah, in what ways? What is a way? And of course, this may sound a bit easy and a bit annoying, but the ways, in fact, comes down, if I understand you well, in selecting the resources that are in the suitcase, right?
In
At least
the
that's
first
what you
one,
presented in the results.
Yeah.
So then the question is, like, how do they choose between the different resources? And of course, they can choose non-historical ones, but then comes the point that Joke mentions. Well, they feel they should do something with history, I guess, in this course with you in front of it. So I'm a bit puzzled about. I think it might be useful to pinpoint a bit more precisely what you are investigating in this course.
Yeah, you're absolutely right, and I think it's something that well, I think we collected a lot of data, and we can say a lot of things, but I'm also a bit struggling myself in what will be the main focus here. Yeah, so we basically we wanted to use the model that we from the first part, and we wanted to see what our students would make of it, and if it was suitable to use in a teacher training program. And the way we did that is to have them design lessons on logarithms, and the what ways that's in the slide here refers to, I think, in what ways in terms of the model.
But the model had also the cognitive demand dimension, if I remember.
Yeah.
And I didn't see it appearing in the results here, or did I?
No, not yet. No, I did not show them yet. No.
Yeah, so that's only to a limited extent that you use the model.
Yeah, well, at least in this this presentation. Yeah.
Thank you. And as I announced earlier, I have to go for some.
You've been here quite some time.
Yeah. Thanks.
Thank you, Paul.
Rahir, you have a further question? No, please unmute.
Yes, just to follow up on Paul's question, because I think that's the nice one. So if you have to answer this again, maybe, how did the model facilitate this design process for the teachers? What can you say about this? This is your main question, isn't it? And it's a great one. So how did it? Could you really see that having an impact on their design choices?
Yes, I think we did, but I did not show that much in this presentation. But I'm going to go a lot of slides ahead. So when we're looking at these results, but then for the second and the third design, you can actually see that they are the stamp is not used anymore, and it's the majority is snippets, and some use stories. And when you combine it with what they wrote in the questionnaires, or how happy they were with their own designs, from the start they were rather positive towards using history of mathematics, and they seem to get more positive about the designs that they made using history of mathematics. I'm not sure. You look a bit like that's not the answer to your question.
It is no, it is, so you can see, and that's then so it shows something in how often these the choices are made for a story. And does it also increase the quality of the stories? Did your course also include for them support on how to actually develop such a story?
Yes, but not as much as we would want, I think. I think the support had several forms. For instance, they got feedback on the designs they made, and we showed them examples. But I think that's the support they got. So we didn't do entire session. Oh, and they also gave feedback to each other, actually. But that depended a little bit on who gave the feedback. If it was rather supportive, but that we didn't do. Eventually, the class was on history of mathematics and not a didactical course or a task design course or something. So it had to be on the side, so to speak.
Yeah, but it would be really interesting for, I don't know if this can be part of your PhD later, to have some more ideas about this, how to create such stories.
Yeah, well, and what the students did write in the questionnaires was, we asked them, are you happy with it, or do you see pros and cons, etc. And they said, we like this, but it takes a lot of time, which we don't have, or which we are unable to have at this moment, especially since we're doing a training program on the side. It takes a lot of materials, which is not in the curriculum or in the textbooks. We have to do research ourselves to find appropriate materials. It takes knowledge, which we don't always have, at least not on all subjects. In our History of Mathematics course, we taught history on numerous subjects, but not we couldn't be complete in that sense. So they also gave, I think, rather understandable reasons why it's also difficult to work with this approach.
Can I follow up here? And Desiree, do you think that I kind of was wondering, is it teachers' role to design such activities? Or should it be rather embedded in some curriculum and programs and teachers just use? Because I can imagine that's really very difficult.
Yeah, well, that's an interesting question. I think, or I don't expect my students or teachers in general to use this approach for every lesson. I would almost say, of course, but I would like to see more of this type of activity in the textbooks, in the curriculum materials, so that the students have some to choose from, and not have to make all of these kind of activities themselves. And for me, maybe that's also good to clarify on. I don't think every teacher should do this in every lesson with every class. But I do think it's something that should be in the repertoire of teachers, and that they make deliberate choices in using this approach, the same way that you think, for instance, you should use technology in your mathematics education, or you should use cooperation, or there are certain things you think are important for your students, and some have to do with reaching a higher mathematical level, and then this is a possible approach.
Yeah, that's very interesting, because when we talk about technology, we actually don't expect teachers design technologies.
No.
We expect them to use technologies,
yeah.
Right? I mean, there are with Peter Boone, who is here, we have, I think, sometimes from time to time conversations on that. Should teachers design their lessons within technology? No, that should designers maybe do. For teachers, it's a kind of extra thing.
But everybody knows that the authors of those lessons, of those book series that Desiree has studied, are actually teachers.
Yeah, exactly. So that's nice that some teachers can, those who become authors, that's for sure.
So I think Desiree should really not only aim at teachers as our audience, but also those teachers who are designers or whoever. You just generally want the way History of Mathematics is used in those book series to improve.
Yeah. Well, I've actually done some sessions with some authors from textbooks, but I agree. Yeah.
Yeah.
And I wonder if there are more questions, because I have a kind of a little bit more general tone for this discussion. Okay. Okay, let me try, and if more questions come, we have still a couple of minutes. So I was wondering, so because I come from the cultural historical tradition, when Davidov worked, and I was wondering generally within this historical community, if Davidov's ideas are present. I was curious because I was never into these things. Davidov's idea was that in order to design the curriculum per se, something that what Rohir was saying, just the way how circle is explained, the way is number introduced, the way multiplication appears for the students, should be done through what he calls historical logical analysis. Because and that's very, very consonant with Freudenthal reinvention idea, I believe. Because indeed, as you were putting it, mathematics is a human activity, and then students can pass through the human activity and then this actually cognitive and motivational thing become joined, become together, because they're motivated because there is a cognitive demand, because they need to understand something. That's how mathematics develop, and if students reinvent, they also go through this. So I was wondering, first of all, if these ideas, if you meet these ideas like at the conferences, in the literature that you read, and what is your own vision towards this kind of a fundamental redesigning of a curriculum in a historical way?
Okay. That's a rather large question.
Yeah.
Well, I think what I see now within our community is the how do I say that? The cross-cultural approach. So it's not, maybe I don't understand you completely, but I think we use now it's more gosh, how do I say this? We think it's important to make mathematics accessible to everybody, to every culture, to also to children who have lower access to knowledge or have come from backgrounds that don't support education that well. And I think mathematics is seen as a very suitable subject for reaching those kind of goals, but then it actually maybe diminishes the focus on culture. So it's it shouldn't be that. Maybe I'm mixing up a bit here, but it should be less nationalistic. Or am I going in the wrong direction here?
No, I mean, I don't think there is right or wrong, but what you're pointing towards sounds to me like ethnomathematical approach a little bit, when we bring what different cultures, and there was studies like on carpeting and on the street mathematics. Is this what you mean? So that we can embed in a curriculum some parts how mathematics exist within non-Western cultures?
Yes, but also that if we I'm thinking about a presentation that I had in a conference in February, how history of mathematics could be used against racism. which well, is another direction, but I'm not sure how that fits in here.
No, I think that's indeed very important in other direction. But thanks. I think that yeah, even these terminological difficulties already for me quite insightful, because that means that this Davidovian ideas and culture and the logical historical analysis is not present in the discourse.
No,
yeah,
not
which is
explicitly,
very not immediately visible. Yeah, which is very understandable. But just to say a couple of words, so he had a kind of a crazy idea that the number comes from comparing units, and that we should at first introduce measurement and only then whole numbers. That whole number is just a subcase of a rational number. So because that's how they appeared in history, they were distances.
It's a bit Greek, yeah.
Yeah, so it's like really turning things upside down, and yeah, that's yeah, and I find it kind of at first in some way challenging. At the same time, when I design my activities, I always find it very helpful to understand how did, like for example, for trigonometry earlier, and how trigonometric circle was developed, or Cartesian coordinates, how they appeared, for which kind of questions, Ptolemy, and so on. So that when you get history, you can design better kind of thing. But then there is no, into your model wouldn't be anyone, any type, because then it's like, it's not possible to see history, it's implicit.
Okay.
But just before you say, so these ideas of Davidov are maybe not explicit with his name labeled on it, but maybe Desiree knows that this Jan van Manen, who was of course director of Freudenthal Institute, was very active in your group.
Yeah, he was a chair. Yeah.
Yeah, exactly. So I don't know his work there, but he must have promoted this idea of reinvention and historical analysis as a basis for the design.
Sure, and now it's actually for me it goes before him. The genetic approach is a reference
that could be,
which is from Toeplitz and which was elaborated on by Schubring. But I don't think that's the same thing that Anna is talking about. But the conclusion is that I think it does relate to one another, but it's not explicitly known in our field, I think. For me,
oh, that looks like it's parallel development. Looks like it's parallel, similar development, and I would be very eager to understand if there are really interconnections, if they have heard about each other, because it's known that Freudenthal was reading Davidov, and Davidov was talking with Freudenthal, so there was interaction. But yeah, okay, so very interesting that it was developing independently. Yeah.
I think we should wrap
thanks.
up.
Yeah, exactly. Thanks. I'm sorry, as a moderator, I allowed a couple of minutes more for myself, which is not a good moderating. But thank you very much, Desiree. I think that was big work in front of you, but very interesting. And thanks for the presentation.
Yes, thanks for listening and commenting and asking questions. This has given me some more inspiration and ideas. And I hope to put it into a next article.
Thanks. Great. Can I also just take a little moment to do the announcement for next month, which is with the mystery speaker. That is, we have a speaker in mind, but we're just waiting for the reply. They think it's good practice not to reveal the actual name before it's been settled. But there will be a seminar again next month on the 14th of April. Thursday, same time, same place. You will get a calendar event for these soon. There will also be, again, seminars in May and June. And in particular in June, we're planning for a real life event, which is going to be special and festive. And it's going to be most likely in Utrecht. And we're even considering having a dinner afterwards with those interested. Yes, it's going to be real party time. So for those of you here, don't hesitate to already put this in your diary. April,
May and June, second Thursdays of the month, except I think we.
And June it will be 16th.
Friday.
Then it's the
no,
third.
no, not Friday. Thursday.
It will be the Thursday, the third Thursday of the month.
Third. Maybe it's not 16 if you have calendar. Okay, I'm stopping the book.
Anyway, we're still speaking to